Hey, welcome back to Perry University. Today we're going to be going over a new topic. We're going to be going over circuit analysis. And today to start out, we're just going to discuss what is a charge, what is an amp, and what is a volt. Like and subscribe if you appreciated it. If not, then no worries. Let me know what can be better or what you liked. Let's start out with what is a charge? So a charge, Q, is a proton or an electron. You know them as usually protons plus one, electrons are minus one, and they're measured in the units of coulombs, or at least their charges. And 1 coulomb, that's going to be 6.24 times 10 to the 18, in other words, a ton of these charges. So for circuit analysis, the best way to think of it is when you see 1 coulomb, or you think about 1 coulomb, think about just 6.24 times 10 to the 18 electrons moving along to somewhere. Because that is the thing that's actually being measured. Every one of these C's moving across this wire in the middle, that's 1 coulomb, and that's just that many electrons. And that's what's actually carrying that charge across from point A to point B. And something to think about here. So an electric circuit facilitates charge Q, from one point to another. And that's all a circuit really does. So now that we kind of have an understanding of charge and a coulomb, what is an amp? So an amp is the rate that a charge moves, and it's really the flow of the electrical current. Current, of course, being I, so anytime you see I, it's referring to current, which is just the rate that a coulomb or charges are moving across a wire. And 1 amp, that is 1 coulomb per second. So in 1 second, 1 coulomb of charges comes by, you got 1 amp. So here's kind of an example to illustrate it. So let's say we have a wire connected to a light bulb. And let's say 3 coulombs pass through that light in 1 second. Well, that would be 3 amps, and that's your current. But what about 12 coulombs passing through the light in 2 seconds? Well, for that, you would just take your 12 coulombs over 2 seconds, which is the same as 6 coulombs in 1 second, which is 6 amps of current. But now on to volt, which in my opinion is a much meatier topic. I think it takes a lot more to understand, and it's the thing that I always kind of struggle with myself, even today. So a volt is nothing more than potential electric difference. You'll also see it called EMF, or electromotive force. And it's always measured between 2 points. Remember, that's a relative term, relative between 2 points, point A, point B. The positive point is going to be a higher potential, and of course the negative point is going to be the lower potential. So think of it kind of like gravity. So here we have a ball. Think of that as like a coulomb of charge. You have the positive, that's going to be your high potential, minus is by the ground where you have basically no potential, and it's not very high in the air, kind of like low voltage, even though it's going to be the same charge regardless where the ball moves. That potential energy, and the energy is really important here, the potential energy in that ball is going to be low. See, falls nice and slow and easy to the ground. As opposed to up here, we have a very high potential and it fell a long way. So to put it in more mathematical terms, 1 volt is just 1 joule per 1 coulomb of charge. Remember, joule, that's going to be energy. So this really saying how much energy is in these charges. How much energy do these electrons hold? That's really what a volt is, their potential energy. And the rate that they move, that's going to be their amperage. So like I said, voltage is just the amount of joules of energy in 1 coulomb of charge. In here, voltage variables, they have to indicate which point has that higher potential. So the positive and the negative, they're going to define that reference direction, and you're going to read it kind of according to how it wants you to read it. So if we look at the left, A is negative 5 volts higher potential than B, even though this is the exact same thing as what's on the right, except on the right, B is 5 volts higher potential than A. So if you look at these two basic schematics, these rectangles, they're basically just some circuit. Don't worry about what's going on there. We just kind of abstract all that away. If you want to learn more about abstraction, there's a link to a video where I talk about abstraction. But just kind of don't worry about what that box represents. We just have these 2 points, A and B. And here, A on the left side is going to be denoted as the higher potential, and B with the minus sign is going to be denoted as the lower potential. But this is saying that across here, V1 equals negative 5 volts. So that's saying A is negative 5 volts higher potential than B. which means we really know that B is actually 5 volts higher potential, but you still read it as such with A coming before B. And now over here on the right side, physically speaking, it's going to be the exact same thing. However, it's just denoted differently. This time, B is labeled as having the higher potential, and A is labeled as the lower potential, and we're saying that B is 5 volts higher potential than A. So it would be true that A would be negative 5 volts higher than B. So as you can see, the plus and minus is important because it's going to be a reference direction, and you have to have them, you have to pay attention to them, and you kind of read it in that order. All right, that's as far as I'm going to go into voltage today. I got another video coming up that's going to be way heavier about voltage and going to do some voltage kind of circuit math problems, if you will. And another video after that that's going to be about conventional current versus kind of what's actually happening. Hope you enjoyed this. Hope you got a basic understanding of charges, coulombs, volts, and amps. And I hope you have a great day.